Hello, I'm Reese Holsworth. This is my lab five, which is the one we get to choose for ourselves. And for my group, we decided to model the dropping of a basketball on a table. Introduction. The goal is to analyze motion from real world data and build a physical model from it. We use position versus time data and we use X and Y for the moving object. The purpose was to, understand motion using physics principles, predict behavior with a mathematical model, and visualize results using closed scripts. So first we have our data collections. So data was obtained from recording a motion video, obviously capturing our group of him. He was basically holding the basketball and then just let go of it and it bounced, and it basically was we are seeing like the oscillation of it bouncing because it was like, the springy ball. We tracked position X and Y over time, use numerical data, obviously. So here are all the points on it throughout the time of it bouncing. Next, the physics principles we use in it. Kinematics, obviously, position, velocity, and acceleration were all matters of it. We assumed a constant acceleration for y and linear motion approximation in x, which assumed was, not too much because it's supposed to go up and down. Model development, obviously, here are the different equations we use to make x obviously linear and then y, be quadratic, so it could change. And we use least squares to fitting to make sure it works. For glow script simulation, we obviously use this data, and we had to make our own glow script from it. Following the ball's trajectory, and we had to compare this to the real world data versus the model. So I'll show you now. As you can see, it's fairly accurate. Obviously, something was a little messed up, but as you can see, it does hit all the points. And yeah. Let me go back to um okay, results. The model closely followed data trends. As you can see, the data trends right here as it goes down. The Y is slowly peaks down lower and lower. Following parabolic motion, and there's obviously small deviations due to measurement errors on close script or tracker. Error assumptions, obviously, we had, assumed constant acceleration, we ignored air resistance. There might be some tracking inaccuracies and, limited data points available. Conclusions, model successfully predicted motion. Closed script was, visualization confirms behavior of the oscillation, what we predicted. Some had questions were, what if acceleration changed, maybe the ball would, bounce more, maybe if we slammed it down, and this lets us, about the real world that we can use real world applications and use physics to apply it to it, including GlowScript, which is pretty cool. Um, and yeah, thank you for watching.